Okay, in this video, I'm going to be talking about the ideal gas law and also Dalton's law of partial pressures. Okay, so we're going to start with the ideal gas law. This relates pressure, volume, number of moles, and temperature at the same time. So this is a little different than our upside down triangle that we've been looking at. We're looking at all those factors, still pressure and volume and temperature, but we're adding in moles as well. So a little bit more chemistry oriented. This only has one value for each symbol. Okay, I'll explain that in just a moment. So this is our equation, PV equals nRT. So pressure, volume equals N is for number of moles, R is a constant that I'll share with you in a moment, and T is temperature. R is constant, meaning it's always the same, and it is 0.0821 liters times atmospheres per Kelvin times moles. Okay, so when it says this only has one value for each symbol, it's kind of going over this label here. So all of our volume has to be in liters, pressure has to be in atmospheres, temperature has to be in Kelvin, and our moles are moles. Okay, we just want to make sure if we have grams, we convert. Okay. And we just went over this piece, okay? This is in that same box as the other formulas that you have on your cheat sheet. And it does indicate all of their labels. So it has this atmosphere, liters, number of moles. It has the constant for you and the temperature being in Kelvin, okay? So you have it all right there, which is really nice. Okay, this is only for ideal gases. So gases with a pressure of about 1 atmosphere or lower and temperatures of 0 degrees Celsius or higher. Okay, on the quiz, you will not have to figure out if it's an ideal gas or not. If you're being quizzed using the ideal gas law, you'll know that that's the equation you're using for those problems. Okay, so here's our example. 2.5 moles of N2 gas has a volume of 55,000 milliliters and a temperature of 300 Kelvin. We want to calculate the pressure. Okay, so if we were to do this, this is our math. To get here, like we've done in our other sections, it probably works best to lay out all of your variables. So we have our moles, we have our volume in milliliters, so we'll have to convert that to liters, which is 5.5 liters, as you can see down here. We have a temperature of 300 Kelvin, so we don't have to convert that. And we're calculating pressure. We can take our formula and isolate our variables so that pressure is on the side. We have N, R, T, and then we divided by our volume. And we get 11.20 atmospheres. Okay, here's example 2. I'll read it, and then if you want, you can pause the video, go through the problem, and try it on your own, and then check your answer. So if 45 grams of carbon dioxide has a pressure of 2 atmospheres and a volume of 4 liters, what is its temperature? Okay, go ahead and pause the video. All right, so we have our equation, which we modify. So if we're doing temperature, then we have pressure times volume. And then we're going to divide that by our R times 1.02 moles. Okay. And we get 95.53 Kelvin. Okay, now you might be wondering how we got this mole when we have a mass for carbon dioxide in grams. So this is where we'd have to do some converting. So we'd take 45 grams of carbon dioxide, we'd find the molar mass to convert it into moles. Okay, and they did that. That's done, but it's not shown here. So that will give us 1.02 moles. Okay. All right, the next one that we're going to talk about is Dalton's law of partial pressures. Dalton came up with this in 1802. He found that gas pressure comes from the collisions of molecules, and it doesn't matter what type of molecule, only the number of molecules. Okay, therefore, at a constant temperature and volume, in a mixture of gases, the total pressure equals the sum of the partial pressures of all the gases. So our total pressure is the pressure of gas 1, gas 2, and gas 3 all summed together. All right, and those numbers are the partial pressures of each gas. All right, so we're going to try one of these. It says, I have a container with helium, oxygen, and argon gas. The helium has a pressure of 2 atmospheres. Oxygen has a pressure of 5 atmospheres, and the argon has a pressure of 3,040 millimeters of mercury. What is the total pressure? So if we look at our 3 gases, we can see we have atmospheres, and millimeters of mercury. So we need to convert to them having all the same unit. So it probably makes sense to convert this to atmospheres. So if we do that, we take 3,040 millimeters of mercury divided by 760 to get atmospheres. And if we do that, we get 4 atmospheres. So we have 2 plus 5 plus 4 gives us 11 atmospheres for our total pressure. Okay, this one's pretty easy. It's just adding, or it might be subtracting if we're trying to find the pressure of a specific gas. All right. Example 2 says, air contains oxygen, nitrogen, carbon dioxide, and some other gases. What is the partial pressure of oxygen if the total pressure is 101.3 kilopascals and the partial pressure of nitrogen is 79.10 kilopascals, carbon dioxide is 0.040 kilopascals, and the other gases are 0.94 kilopascals. Go ahead and pause your video, try this one, and then come back and check your answer. Okay, so with this one, we have the total pressure, and we have pressure for 3 of the 4 gases that we're looking for. So our total is there are 4 gases, oxygen, nitrogen, carbon dioxide, and the other. If we want to find oxygens, we're going to take our total and we're going to subtract out the pressure of the other 3 gases. So we take 101.3 minus our nitrogen, minus our carbon dioxide, minus our other gases, and we're left with 21.22 kilopascals of oxygen would be our answer. And that's it for our notes. We are done with all of the gas laws, and we will move on to some lab work where you'll get a chance to apply all of the gas laws next week. Please go ahead and try the homework. If you have questions, let me know. The answer key is on Schoology for you to check your work. Thanks.